Alright, in this section we talk about derivatives of trigonometric functions. And so here are the six trig functions. So when you take the derivative of sine, you get cosine. When you take the derivative of cosine, you get minus sine. And then all the rest of these follow from those first two, but derivative of tangent, secant squared, derivative of secant is secant tangent, derivative of cosecant is cosecant cotangent, and derivative of cotangent is negative cosecant squared. Alright, so if you want to find the first derivative of y equals x squared sine x, you're going to use the product rule. So the first times derivative of the second plus the second times derivative of the first. Well, derivative of sine is cosine. Derivative of x squared is 2x, and there you go. Here you're going to use the quotient rule, so the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, which is what you get right here. And the derivative of secant, we know, is secant tangent. Derivative of 1 is 0, but the derivative of tangent is secant squared. And the bottom you square it. And now you can multiply that out, and you get this. You can factor out a secant, your tangent squareds cancel, and you get this right here. You can simplify this part here by letting secant squared equal tangent squared plus 1, and that way some stuff simplifies down here. That's how I got this to simplify down to tan x minus 1. Alright, so if you've got an original function of 4 cosine, what's the first and second derivative? Well, this is just a constant times a function, so the derivative of cosine is minus sine with a 4 in front of it. And the derivative of sine we know is cosine with a negative 4 in front of it. And they talk about how it oscillates back and forth. Now here's a weird one. They ask you to find the 27th derivative of cosine. Well, you might say, how am I supposed to do that? Well, just start taking the derivative and you'll see a pattern here. First derivative of cosine is minus sine. Derivative of sine is cosine, so minus derivative of minus sine is minus cosine. Derivative of cosine is minus sine, which cancels with the minus, giving you positive sine. And derivative of sine is cosine. So after taking 4 derivatives, you're back to the original function you started with. So every 4 derivatives, you cycle back to the original function. So the 4th, the 8th, the 12th, 16th, 20th, 24th derivative are all going to be cosine. So then you know it's going to cycle through again to minus sine squared, minus sine x, minus cosine x, and then sine x. So you can figure out with a certain amount of logic what the 27th derivative of cosine is. They give you two unusual limits here. They tell you the limit as theta approaches 0 of sine theta over theta equals 1, and the limit as theta goes to 0 of cosine minus 1 over theta equals 0. Here they ask you to find this limit, and you have to write it in this form. So whatever you have here, this guy has to match up. So since you have a 7x there, you got to write this with the 7x as well. So that's how you're multiplying by 7 and swapping out the 4 with the 7, so that you can say that this part goes to 1. When you take the limit of this part, it goes to 1, and then you get your answer. Otherwise, you wouldn't be able to get an answer for that one. And we do the same thing here with this one. At some point, we're asked to use the limit for cosine theta minus 1 over sine theta, or cosine theta minus 1 over theta. So they first multiply by 1 over theta, top and bottom. And to do that, they do that because this part right here is exactly what you had right here. And we know that the limit goes to 0 for that part. So we know that that part is going to go to 0. And the bottom is going to go to 1. And so we know from these two special limits that your denominator goes to 1, your numerator goes to 0. And so 0 over 1 is going to be 0. It's the only way you can analyze this one is to do this unusual multiplying top and bottom by 1 over theta in order to see what it's doing there. Alright, so let's look at some of the questions that WebAssign is going to be asking you to do. It's these questions in this order. So the first one says take the derivative of x squared plus cotangent. Well, x squared is just 2x. Cotangent is negative cosecant squared according to the derivative rules, and so there's your answer there. Take the derivative of theta squared times sine theta. Well, that's a product rule. First times derivative of the second plus the second times derivative of the first, and you just simplify it down. Here, this one you can take the derivative of each one just directly. Derivative of sine is cosine. Derivative of cosine is minus sine, and then you simplify it. Here you can use the product rule. Sine times derivative of cosine plus cosine times derivative of sine, and you end up with cosine squared minus sine squared. This one you got to use the product rule. So you're using the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. And derivative of x is just 1. Derivative of this one, the derivative of 2 is 0, but derivative of tangent is secant squared, but it's got a negative in front. And you can multiply everything out, and that's about as simple as you can make it. Here you're using the quotient rule again, so you got the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. And you multiply everything out. And you can write tangent in terms of sine over cosine and secant in terms of cosine, and it helps to simplify things down a bit, but I don't know, not much. This one, again the quotient rule, bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. And derivative of 1 is nothing, but derivative of secant is secant tangent. Again, derivative of 1 is nothing, but the derivative of secant is secant tangent, it's got a negative in front. And you expand everything out and some terms cancel, and you're left with this guy here. 21, you got theta times cosine times sine. So you got a couple of things here. You can look at this as one function theta and another function cosine sine. So it's the first times derivative of the second plus the second times derivative of the first. Okay? And the first is just theta. And the second, when you take the derivative of this, that's the product rule. So it's cosine, derivative of sine, plus sine, derivative of cosine. And here, the derivative of theta is just 1, just like the derivative of x is 1. And now you multiply everything out and combine like terms, and you get this. You can even go even further and get cosine 2 theta if you want, and sine 2 theta if you want. You don't have to, but it's just you can write it simpler if you want. Alright, so this one, cosecant is 1 over sine, and so you can think of it as a quotient rule. So it's sine, derivative of 1 minus 1, derivative of sine over sine squared. Well, the derivative of 1 is 0, so this first part goes completely away. But the second part is negative 1 times cosine, which is negative cosine over, and the bottom is sine squared. 1 over sine is cosecant, and cosine over sine is cotangent, so there you go. You got this guy. Here, when you take the first derivative, you get 1, and you get cosine, and now you can plug in pi for x and get your slope, and use that slope with the 1 point to find your equation of a tangent line. To take the first derivative here, you're going to use the quotient rule, or product rule. First times derivative of the second plus the second times derivative of the first. Product rule here, first derivative of the second plus second derivative of the first. Quotient rule, the bottom derivative of the top minus the top times derivative of the bottom over the bottom squared, and you get this. Now they want you to do the second derivative, so it's the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared, and that takes a little bit of work, because in order to take this derivative here, you got to use the product rule for that part. You don't have to for that one, but this first one you got to use the product rule. So first derivative of the second plus second derivative of the first, just for this part. Derivative of sine is just cosine, and this one no need to take derivative there, but there you're going to get 2 theta. Some stuff cancels and you get your answer there. Alright, what's the derivative of this? Well, it's the bottom times the derivative of the top, which is just 1, minus the top z times the derivative of the bottom, which is this here, all over the bottom squared. And you can expand everything out, factor out a secant z plus tan z, and it cancels with the denominator. and you end up with that as your answer for your derivative.